Okay, so in this problem we've got square roots. So we want to find perfect squares that are factors of these numbers underneath the radicals. Because if we can do that, then we can simplify them. So let's make a list of our perfect squares. Starting with 2. 2 squared is 4. That'll help us out with 2 square roots of 8 because 4 is a factor of 8. And then we have 3 squared. That's 9. That doesn't help us with either of these. 4 squared is 16. That also doesn't help because it's not a factor of either 8 or 50. 5 squared is 25. And that's a factor of 50. 50 is just 25 times 2. So that will help. And that's as much as we need for this problem. So we'll rewrite the first part of the problem, 2 square roots of 8, as 2 times the square root of 4 times the square root of 2, because 4 times 2 is our 8. And the second part we will rewrite as square root of 25 times the square root of 2, because that is 50, square root of 50 when you multiply those. So we know that the square root of 4 is just 2, so I'll rewrite that as a 2. And we know that the square root of 25 is just 5. And then we'll write down the square root of 2 next to it. Now this first part we've got 2 times 2 times square root of 2. So we can go ahead and multiply the 2's that are not underneath the radical. So that's 4 square roots of 2. And then we have plus 5 square roots of 2. So altogether we have, since they're like terms, they're both square roots of 2, we have 9 of those square roots of 2. And that's how that one works.